So based on what we did before, this chapter should be like the easiest chapter in the entire textbook because we already know how to do hypothesis tests and we already know what to do with two samples because we did that in the last chapter. So this is going to be a super easy chapter. It's going to go pretty fast, and the chapter after this is kind of similar, and we're going to go fast through that one too. Okay, so I promise you, even though it looks like we have a lot of notes towards the end, it's not that much work. Okay. So we have hypothesis testing for two samples. Whenever we have two samples, there's two different ways they can be related. Remember, they can be independent, where there's no relationship between the two samples. There are probably different people in the different samples, and the samples are likely to have different sample sizes. So really no relationship between the two samples. Paired samples, on the other hand, are when observations in one sample can be paired with an observation in another sample. So paired samples always have to have the same sample size. Usually it's the same people in the two different samples, or there's some sort of relationship like before and after with paired sampling. Okay. I would like you to cross out this section. We'll focus on independent sampling. I used to separate the two sections into two separate guided notes, but I combined them this time because they're so similar. So let's just erase that. Okay. So I think the easiest way to talk about two sample hypothesis testing is just to remember what we did with one sample hypothesis testing, which was all the way back in chapter 9, which was a while ago. So let's talk about hypothesis testing for that one sample section that we did. And well, there's a lot of stuff that went into it. First of all, with one sample hypothesis testing, you were given a really long paragraph. It gave you a lot of information, and one piece of information they gave us was the population mean, right? Does anyone remember the symbol for population mean? Rhymes with Pew. Mu, good, all right. And remember, this isn't like the actual population mean, but it's like what someone says the population mean is, right? So that goes in our hypothesis. We're also given the sample size, which I think we all know is n, right? Okay. We're given the sample mean. What's that symbol? X bar, perfect. We're also given a standard deviation. Now, it could be S or it could be sigma. It depends on the question, but we're given one of these standard deviations, okay? Finally, we're given this thing called the significance level, which is called alpha, okay? I explain alpha as it's the probability of making a type 1 error, and we can't make it too small because it will increase the chance of a type 2 error. So that's kind of what alpha is. Okay, now with one sample hypothesis testing, the first thing we had to do was answer our assumptions. And the big assumption we had to make was, is our sample size bigger than 30, right? That was the big thing. Now, some questions didn't have a sample size bigger than 30, and we could still do the question because there was something about the population being normal, right? So if either one of these things are true, we can still go on with the question and, well, do our solution, right? All right. All right, oh, there you go. All right. Now, another assumption that I made, which really is an assumption, but we really have to figure out which Minitab test to use, and that dependent on if we're given sigma or if we're given S. So usually, oh my goodness, it is given, right? So we usually go in the question, we're like sigma's given, S is given, and that tells us which Minitab test to use. Okay. Now, for our one sample hypothesis testing, we had a null and alternate hypothesis, which I don't know if you remember, but the symbols for our null and alternate hypothesis were H0 and H1, right? The null and alternate hypotheses both talked about mu because we wanted to figure out what mu was, right? The null hypothesis always said that mu is equal to some number, and the alternate hypothesis still had the same number, but it said greater than, less than, or not equal to. You really just had to parse through the question and see like where it says greater than, less than, higher than, lower than, wider than, narrower than, something like that. And well, that told us what that was. Okay. Next, we had to find this thing called the confidence level. That was a formula you had to memorize. It's so long ago, I'm just going to give you the formula, but do we all remember 100 times 1 minus alpha? Yeah, I think that's kind of ringing a bell, right? It was something you had to memorize for hypothesis testing, and it's what we typed in Minitab. Okay. Next, you had to find a p-value that told you if you rejected or failed to reject the null hypothesis. And you use that, well, you use Minitab to find it, right? So use Minitab. Okay. Now, there were two tests on Minitab that we used to find the p-value. One was the one sample z test, and the other was the one sample t-test. Okay. Now, let's say we were doing the question and you were given sigma, or the population standard deviation. Is sigma the one sample z-test or the one sample t-test? Yeah. Z, right? So if you're given sigma, it's the z-test. If you're given S, it's the t-test. That's how we made the distinction as to which one that we used, right? Okay, cool. Finally, I didn't really make space for this in the notes, but I'm going to put it at the bottom. If P was less than alpha, do you remember if we rejected or failed to reject? I know it's been a while. It's actually reject. Okay, so if P was less than alpha, it's reject. If P is greater than alpha, we fail to reject. Okay, after that, you write your conclusion, but we'll talk about that later. And you're pretty much done the question, right? So all of this was in the one sample hypothesis testing section. There were a lot of steps, but like once we learn these steps, doing the two sample hypothesis testing is super easy because the steps are so similar. And even if they're not similar, it's like a very slight difference, okay? So let's talk about two samples. Now, with two samples, well, I think the obvious difference is we have two samples. So we'll have a sample 1 and we'll have a sample 2. Okay. Within each of these samples, you're going to be given a lot of different pieces of information. The first piece of information, well, sample 1 represents a population mean. Sample 1 has a sample size, it has a sample mean, it even has a sample standard deviation. Okay. Same thing with sample 2. You're going to be given mu, n, x bar, and s. Now, it's kind of confusing to talk about the sample size as n if you don't know which sample it refers to, which is why with two sample tests, we use these things called subscripts, which are just numbers underneath our variables, which tell us which sample we're talking about. So if you see S2, you're talking about the standard deviation of sample 2. Okay. You're also going to be given an alpha, which is a significance level, same thing as the one sample test. Okay. Assumptions, basically the same thing as we're used to doing. In our assumption section, we need to check to see if our sample size is large enough, but now we have two sample sizes. So the same thing that we did for the last chapter is true. We need to make sure that both N1 and N2 are both bigger than 30. Okay, so both of them have to be bigger than 30. If either one of them or both of them are less than 30, you can still do the question. You just have to check to see if there's something about the population being normal. So, or population normal. Okay. Now, our second assumption, which isn't really an assumption, it's just telling us what to do later on. We need to figure out what test to use, and that's going to depend on if we are given independent or paired samples. Okay, and actually, we know how to do this because the confidence interval section, the last one that we did, it's the same difference, two sample T versus paired T. We'll talk about that. Okay. I think the biggest difference between one sample and two sample hypothesis testing is the null and alternate hypotheses. They're going to look a little bit different, okay? And the main reason why two sample is different than one sample is because we're asking ourselves a different question in this section as we did before. For our one sample test, we actually wanted to find the value for mu. So we wanted to say, like, is mu equal to 5, or is mu equal to 6, or is it less than 6? Okay. Two sample tests, we actually don't care about what mu1 or mu2 is. We're actually just comparing the two samples. So the big question here is, are mu1 and mu2 the same? Not what value are they? Okay. So because of that, our null hypothesis is going to look like this. Okay. It's still going to talk about mu, but instead of figuring out what mu is, we're asking ourselves if mu1 is equal to mu2. Okay, that is the overarching question for hypothesis testing when we have two samples. Okay, are the two means equal? Now, no matter what question you have, this is always going to be the null hypothesis. There's no creativity here. It's always going to be this, okay? The alternate hypothesis is going to be a little bit different. Okay, we'll still have mu1, mu2, but we're going to have either a greater than, a less than, or a not equal to sign. That looks like a face. Oh. But that's what our alternate hypothesis is going to look like. Okay, any questions so far? Cool. Now, once we're done making the null and alternate hypothesis, I swear pretty much everything is the same. The confidence level formula, same symbol, same formula, right? 100 times 1 minus alpha. You're still going to find the p-value using Minitab, okay? And after you use Minitab, the way that you make your decision is the same. So p less than alpha, you reject. P bigger than alpha, you fail to reject. The conclusion making process is the same. The only slight difference here is instead of using the one sample z-test and the one sample t-test, you're using the two sample t-test and the paired t-test. So basically the same formulas and Minitab outputs, Minitab buttons that you use are going to be the same. If we have paired samples, which test do we use? Paired, right? That's a pretty easy one, right? So this is paired. And if we have independent samples, it's the two sample t-test. Okay. So once we know how to do the one sample hypothesis testing, which you have to know anyway for the final exam, right? The two sample t-test or the two sample hypothesis test is pretty much the same thing. The only difference is like there's slight caveats in like the assumptions and the tests that we use on Minitab. The only big difference is the null and alternate hypothesis. That's all that's different. Okay. I do have a list of steps for doing these. I don't really know if they're that helpful, but I like step-by-step instructions. I think they're useful to me at least. Before you do a hypothesis test, the first thing you're going to do is determine what test you're going to use, right? Do I have independent samples? Do I have paired samples? If it's independent, use the two sample t-test. If it's paired, use the paired t-test, okay? Step one, rating your assumptions. Are my sample sizes big enough? Is the population approximately normal? Step two, writing your null and alternate hypothesis. We just went over this, right? Mu1 equals mu2, less than, greater than, not equal to. Step three, you're going to calculate your confidence level. Step four, you go into Minitab and you're either going to use the two sample t-test or the paired t-test. I basically have a list of instructions for the two sample t-test. I have a separate list of instructions for the paired t-test. So whichever one you do has a different set of instructions. Step 5 and step 6 are the exact same steps as we did in the previous hypothesis testing section. So there's really nothing new to learn here. It's just like learning what to click on Minitab. All right, let's go through an actual example and I'll show you how easy this actually becomes, okay? Personally, to me, the hardest part about all of these questions is parsing through the question and figuring out what letters go with what numbers. So since we have a two sample hypothesis test, we're going to have a sample 1. We're going to have a sample 2. Okay. Let's read through the question. We have scores on this test ranging from 0 to 500. In a recent year, the sample mean score for students using a computer was 309 with a sample standard deviation of 29. For students not using a computer, we have a sample mean of 303 with a sample standard deviation of 32. Assume that there were 60 students in the computer sample, 40 students in the not computer sample. I want to know if the population mean scores differ at the 0.05 level. Okay, now before I do the question, the first thing I want to do is figure out what sample 1 and sample 2 represent. It doesn't really matter which one sample 1 or sample 2, but to me, I always go for the first one introduced being sample 1. So going through my question, it says students using a computer was my first sample. So let's just make computer sample 1, okay? And then no computer being sample 2. Okay. Now, for each of these samples, we're going to have a sample size, N1, a sample mean, X bar 1, and a sample standard deviation, S1. Same thing for sample 2, except we have 2's, right? 2 and S2, okay? Can someone tell me what my first sample size is? Michael. Is it 309? Ooh, 60, right? Yeah, so this question, I know is kind of mean for me to do it like this, but the sample sizes are actually introduced later in the question. I set it up to make you think it's 309 because it's the first thing that was introduced. But the sample sizes are actually introduced in the very like last sentence of the introduction here. It looks like 60 is the size, sample size of our computer, and it looks like 40 is the sample size of sample 2. Okay. What's the sample mean of my first sample? Well, we already said it. 309, right? Okay. The first standard deviation is 29. The second mean is 303 and a standard deviation of 32. Okay. Cool. We got through the hardest part of the question, parsing through all the information. The only other thing I would write is maybe alpha is 0.05, right? That might be a good thing to write down. Okay. Step 0, before I even do the question, I need to figure out what Minitab test I'm using. I have 2 samples, right? So I just need to figure out if I have independent versus paired. Who thinks I have paired samples? Who thinks I have independent samples? Nice. Okay. I feel good. I feel like I taught you the difference very well. We know the difference between these two. We have independent samples. Okay. If you're confused why I said independent, the biggest hint here is the sample sizes, right? Sample 1 is a different size than sample 2. So there's no way I can pair together my sample 1 observations with the sample 2 observations. There'd be things that are left out, right? Another big hint is it looks like sample 1 has a completely different set of students as sample 2. They might not even know each other, right? Okay. If we have independent samples, which test are we using? 2 sample T or yeah, 2 sample T, right? 2 sample T test. Okay, so now the question's kind of set up for us. We know what test we're using. We have all our information. Now all we need to do is go through our steps. The first step is looking at our assumptions. Now, our assumptions here, we just need to make sure that both our sample sizes are bigger than 30. Let's do sample 1. N1 is 60. 60 is bigger than 30, right? Sample 2 is 40. 40 is bigger than 30. So we're good, right? Looks like our assumptions are met. Now, if both of my sample sizes are bigger than 30, like this question, do I need to go in and say the population is normal? No, right? Because we already said that the sample sizes are bigger than 30. The only reason you would write population normal is if like one of the sample sizes was less than 30, or both the sample sizes were less than 30. If both of them are greater than 30, that's it. We're pretty much good for the assumptions. Cool. All right. The null and alternate hypotheses. This is the only difference, the only big difference between what we did before and what we do now. The null hypothesis is always going to be mu1 equals mu2. That's always the question. That's always what we start out with for 2 sample tests. So I'm just going to write that down. There's really no creativity here. HO mu1 equals mu2. Okay. The alternate hypothesis always has the same symbols as the null hypothesis. The only thing different is the equal sign changing to a greater than, less than, or not equal to sign. Okay, let's take a peek at the question. My biggest hint is usually the last sentence in the paragraph tells you what symbol to use. In this case, it's the second to last sentence. Can you conclude that the population mean scores differ? Is there anything about less than, greater than, taller than, shorter than, anything like that? So what symbol are we going to use? Timothy? Not equal to, right? So if there's nothing that states bigger than, smaller than, it's not equal to. Okay, so that's our null and alternate hypothesis. We are good. Let's go to the significance level alpha. That's given to us in the question. It's 0.05. The confidence level is the same formula that we're so used to doing for hypothesis testing. 100 times 1 minus alpha, right? It's always this. Okay, plugging in alpha, we get 1 minus 0.05. I like to do the subtraction first to get 0.95, hit it with 100, and we get 95% as my confidence level. Cool. All right, any questions on what I did here? Okay, what I'm gonna do next is I'm gonna show you what to click on Minitab, okay? I'm gonna follow the directions for step number 4 here. So if you wanna follow along with me here on the list of instructions, that's what I'm following, okay? In step 0, we said we're using the 2 sample t-test, so that's what I'm going to do, okay? So let's go to Minitab. I guess I should open it again. All right. And I'm just going to follow the directions. I need to click on stat, basic statistics and two sample T, right? Okay. At this point, it kind of seems like you can't type anything because we need to change the drop-down menu to say summarize data because we're given a summary of all the data, right? So summarize data. Okay. At this point, I just need to write down my information. I know that N1 is 60, X1 is 309, S1 is 29. This is so cool to me. I don't know why. This is like my favorite part of this whole class, is just writing the numbers down. Okay, so I wrote down all my numbers. Now, at this point, it's very tempting to hit OK, but we still haven't told Minitab what our confidence level was. We also didn't tell us what the symbol was in our alternate hypothesis. So that's why we click on options, okay? The confidence level says 95%. I mean, it is 95%, so I'm not gonna change it. But if I calculated the confidence level to be 99%, I'd have to change it, right? The only thing else that I'm gonna change is the alternative hypothesis, okay? The drop-down menu has 3 different options, a less than, a not equal to, and a greater than, okay? It's very simple. If your alternate hypothesis says less than, do the less than, right? If it's not equal to, choose not equal to, which is what I'm gonna choose, okay? I'm gonna hit okay. I'm gonna hit okay again. And I get a lot of information on here, right? Now, before we really focused on the estimation for difference thing that gave us the confidence interval, but we only care about the p-value since we're doing a hypothesis test. So our p-value is down here under test. 0.343 is our p-value. Okay. Any questions on Minitab? All right. Now, once we're done Minitab, everything in this question is basically the same as what we did before. Our p-value is 0.343. We need to decide which conclusion to make. So do we reject? Do we fail to reject? And I don't know if you remember this, but we did this by comparing p and alpha, right? I personally like to write them side by side. If I don't write 2 numbers side by side, I cannot tell you which one's bigger. I don't know why. So p is 0.343. Alpha is 0.05, right? Which one's bigger, P or alpha? P, perfect. And if P is greater than alpha, do we reject or do we fail to reject? And if you don't remember, I actually have it on my list of steps here. So if P is greater than alpha, what do we do? Fail to reject, right? Don't reject, fail to reject, all the same. Fail to reject. H. Okay. Finally, we have to write our conclusion, which to me, I always like the template because it works for either of the sections. We're going to piece together 2 parts of the sentence. The end of the sentence is always going to be, is it H0 or H1? We can always peek back. Looks like, oh, I actually didn't put that on here. Well, okay. Well, we actually have to remember it this time, I guess. It's always going to be H1. Right? We're always ending the conclusion with H1, no matter what decision you make, okay? Now, if we forget what H1 is, let's just peek back. H1 says mu1 is not equal to mu2, so I'm just gonna write that down. Mu1 not equal to mu2, okay? Now, the beginning of the sentence depends on if you fail to reject or reject. Since we're failing to reject, does anyone remember if it starts with we conclude or not enough evidence?
There's not enough evidence.
Good, not enough evidence. So because we fail to reject, say there, oh gosh, here we go. There is not enough evidence to conclude that, well, mu1 is not equal to mu2. So what this means is basically you have the situation. We think that mu1 and mu2 are different, okay? We have a hunch. Based on the information that we're given, we actually don't have enough evidence to say that the alternate hypothesis is true, right? So now we're kind of just stuck with our beginning statement. We're not accepting that HO is true, but we're saying that we don't have enough evidence to say that something else is true. Okay. Any questions on what I did for example 1? All right. Then how about this? Example 2 is very similar. I do want to give you some time to work on this, but I do think this question is worded very badly, okay? So before we start it, I do want to just harp on this one thing, okay? When you make your alternative hypothesis, you go in the last sentence of the paragraph. You see if there's something about greater than, less than, not equal to, something like that, right? Okay. The end part of this paragraph says this. Can you conclude that the mean hours spent per week on the internet has increased between 2010 and 2014? Now, I promise you, I'm not going to put like, I don't think the final has anything worded this badly. Okay. I don't think your homework has anything worded this badly. It's just this question. Okay. But let's just think about it. Okay. If we're increasing between 2010 and 2014, which one is bigger, 2010 or 2014? 2014, right? So we're saying that this guy is the bigger one. Okay. So this one is bigger. This one is smaller. Okay. You'll thank me for writing that when you get to your alternative hypothesis. Okay. All right. How about this? I'm going to give you like 5 minutes. I want you to just work through this. Try writing out your answers. Even on the back page, you can write out your answers because I give you the p-value. And then we'll come back. Right. Let's come back up to the front here. Lots of steps to go over here, right? So this was about a poll asking how many people spent time on the internet. We did 2 samples, one in 2010 and then one in 2014. As I was walking around, I think everyone made sample 1 2010 and sample 2 2014, right? Cool. All right, so the first thing I did was, who did I get to write down the information? That was, I forget who wrote that down. Oh, I got Ashton to write it down. I'm not going to ask you to explain all that because there's a lot of stuff going on there. Do we all agree with what Ashlyn wrote down here? All right. Step 0 was just figuring out what Minitab test to use. This was that Gavin? Oh yeah, Gavin. Why'd you say the 2 sample t-test? Yep, they're independent, right? The 2 samples are different sizes. There's really no like guarantee that the first sample people even know the second sample people. So I agree with that. Step 2 was writing our assumptions. That was Lily, right? I guess really not much for you to explain there. Our sample sizes are bigger than 30. Step 2 was Carter, writing down our null and alternate hypotheses. All right, Carter, do you want to explain why you said less than here?
Because the 2010 is less than 2014, increase between.
Yeah, perfect. I will say that the way I wrote this question was kind of mean, just because it does say increase. So when you see increase, like I would just write a greater than sign, right? But this one is just worded weird. So even though it says increase, it's really a less than sign. I promise I'm not gonna do something like that to you on the test. I've looked at the final. It doesn't try to trick you up like that. And I don't even think the homework does that. So yeah, we just have a less than sign. Step 3 was Michael, writing down the confidence level. I guess I don't really need you to explain this because it's just plugging into the formula, right? All right. Next up is Minitab. I got Miranda to write up all her information here. I really like how you wrote up all the stuff up here to get our p-value. Does anyone want to see me click stuff on Minitab, or I don't know. I feel like you guys are pretty good with the 2 sample hypothesis test. I mean, it's kind of all written up here. If you want to see it, then I don't know. I can show you after class or something. But this is pretty good. All right, our p-value is 0.001. I guess I'm not going to get you to explain that either. All right, step 5 was Mackenzie, right? Or sorry, Michaela. Michaela, there we go. Oh man. We want to decide which we're going to do. Do you want to explain why you said reject? Yep. Yep. So all we do is compare P and alpha. Step 4 is writing down our conclusion. Kaya, do you want to explain how you got your conclusion? Uh-huh. Yeah, because we reject, you start with that, and then it's always H1 at the end. So it doesn't really matter what happens. It's always H1 at the end of your sentence. All right. Any questions on how to do the 2 sample t-test? All right, now this is actually where I left off on my last class. We probably do have enough time to do example 3, but I don't think you guys mind leaving like 6 minutes early, do you?